Can someone see earth is round standing on the earth? That is a question. How nice it would be. If I have, if I am standing on a flat ground with no pollution, because if pollution is there, you cannot see at all. Very few distance you can see. But if person is standing on a ground and he is watching the earth, can he see that earth is round? Okay. So if I have a, or I'll take bigger one. Okay. I have probably bigger one that I'll try. Okay. I really have the bigger one. Okay. This is bigger one. Okay. If this is not round, I have another bigger one. Okay, this is probably this is probably round. This is big one. Okay, this is not round. So if person is standing here somewhere he is standing here, then somewhere he is standing here, can he see that further next it is going round? Is it possible? Like someone is standing on a mountain and he can see the surface on which he is standing, the surface is going down the way it happens in mountain. So if I stand on a flat region on earth, can I see that earth is going down? That's way I can say earth is round. Is it possible? Now, what formula we deduced? So consider this is consider this is consider this is cross section of the earth. If if this is the earth, if this is the earth, then I make a cut. I make a cut, chop, and this is the cross section. If this is the cross section, then person is standing somewhere here. This is the person standing, and person is standing here and he is seeing like this. Okay, if person is very small in front of earth, then he will see very little. Person is very tall, he will see far. Person is very tall, he will see this big. This big he would see. If person is very small, very small, then he would see less distance. More and more less he see, he would tend to see the flat. More and more he can see, he would tend to see the round. So a person who is very tall, he can see the earth round. How a person can be taller? Maximum person can go 6 feet, 7 feet, maximum 1 or 2, maybe more than 7 feet, but 6 feet or 7 feet. With 7 feet, you can hardly see 2 to 3 miles. That's it. Okay. What is the equation for calculating how far he can see? We calculated. So, if this is the earth and this is the radius of the earth, this is the radius of the earth. Now, person is standing here. Okay, if this is the radius of the earth, this is center of the earth, then person is standing here. Okay, and they from here he is watching the earth like this. This is the person. This is the person. So this distance, and now from here there is a radius. So this radius and the person he is watching. So this location and this is the person. It is something like this. This is the radius. This is the and this is the person he is watching. This is 90 degree. And person he is watching, then this is the center of the earth. This is R, this is R, and this is height of the person. This is D. And this is kind of a earth. Then if person is watching, if person is watching, this is the person watching, this is D distance he is watching, and this arc is S. This is radius of the earth R. This is S. Then this is again R. R plus H is the height of the person. R plus H forms the hypotenuse. This is what we talked. So this is r plus h. This is r. This is perpendicular. This is angle is perpendicular. This is d. This is r. This is r plus h. So the d is r plus h whole square minus r square root as per the Pythagoras theorem. That is h square plus 2rh square root. If I take h as very small in comparison to capital R, that is radius of earth, then the person is able to see d equal to square root of 2 into r into h. H is going bigger and bigger, d will go bigger and bigger because square root of 2 into r into h, where r is the radius of the earth. There is another calculation. If this is this is if this is kind of earth, and these are the two radiuses, this from here there is a d distance, and here man is standing. If that is the case, then two places it make angle theta. Okay, this is one place, this is another place where person is standing. This is the curvature of the earth. Person is standing here. This is curvature of earth. Is it making angle theta? From here to here, this angle is 90 degree. If that is the case, then cos theta is r divided by r plus h. Cos theta, the angle it forms, the distance is seen. Okay. So if person is standing like this, and he is seeing up to this point as d, then if this is the angle, this is the person standing, he is seeing up to here, if this is the angle, then theta, cos theta equal to r divided by r plus h. Theta equal to cos inverse r by r plus h. Now theta, if I multiply by r theta, then it gives me the arc. R theta is the arc. R 2 pi and theta is 2 pi, then it is become the full arc of the circle, 2 pi r. So that is in radian. So if theta equal to cos inverse r by r plus h, then r theta equal to r into cos inverse r by r plus h. R theta is the s we are talking. If this is the earth and person is standing here and he is watching from here, he is watching here. Okay, this is d. Then this curve is s. This is angle theta. Okay, if this is angle theta, then this s is r theta. R theta equal to r cos inverse r by r plus h. R theta is s. Then s, for small h, s r is equal to d. Then d equal to r into cos inverse r by r plus h. Also we can calculate the d. Or if I know the theta, then tan of the theta is d by r. Tan of the theta is d by r. D equal to r plus h whole square minus r square. At the end, it will come as a square root of 2 into r into h, considering h is small. H square will take it out. So same 2 square root of 2 into r into h. Square root of 2 into r into h. So tan theta equal to r square r plus h whole square tan theta. If this I consider as theta and this is perpendicular, then tan theta will be perpendicular by base. Perpendicular is d. D is nothing but r square r plus h whole square minus r square. Okay, so square root, that will come at 2 into r into h. Square root divided by the r, that is tan theta. Theta equal to tan inverse, then a square root of 2 into r into h by r. Now s equal to, or d equal to r into tan inverse 2 into r into h square root by r. This way also we can calculate the d. Okay, that is the scenario. But perfect would be that don't estimate r and d together, whatever it is, but that is the calculation for calculating how far a person can see based upon the height of the person. So if someone is standing on mountain, then person height is growing. Okay, can someone try from Mount Everest? And he can see in the why we are taking example of Mount Everest is because Mount Everest north side is Tibetan plateau, and its population is negligible. Means it is still unspoiled region. So air is clean and person can see north to it. That is one fundamental. Second fundamental is that what is the height of Everest? That is around 29,000 feet, 8,848 meter, not kilometer, meter. So that is the height. So we will fix in formula D equal to a square root of h square plus 2rh, or if h I take it out, okay, then it will be 2r into h square root. But when now there is another place with theta. We are talking about theta, right? If theta is very small, theta, if person is standing here and he is watching the earth like this, if this is the d is the distance, if this is d is the distance, and this is the r, this is the s, the curvature he is seeing. Okay, we take s equal to d, considering this theta is very small. But if theta is growing, because he has to see the curvature, right? If theta is growing, then this d and s will not be same. The point where S and D are not same, that point I can take that if someone is seeing that point where S and D I cannot take approximation as same, then he can see the curvature. This is our philosophy. Okay, if someone in calculation we are taking D and S together, D and S, if we are taking into consideration where D, the D when person I is hitting the ground D and person is standing on the ground, that ground curvature S, that is the arc. If these are not, if person is 6 feet high, then this D and this curvature would be same I can take. Okay, it is that small. But if it is going below a limit, then earth will make round, and there this d and this curvature, because it is going down, it is not flat, it cannot be taken same. The point it is not being taken same, that point we can take as different, and that angle from the center of the earth we have to calculate the angle. At what angle it will not be the same, I can consider s equal to do, I cannot consider s equal to do d. If that is the case, then I have to find that angle. If someone is making, so first I have to calculate the d. How much is the d someone is making when he is standing on Mount Everest, when he is seeing north in a clean air? And then what is the formula that makes S and D different? At what angle the earth curve and the D length, what his eye is hitting the ground. If I am standing like this and my eye is hitting the ground, that length, and where I am standing, from there earth is making curve, that arc and this length, if they are different, then at that moment what is the angle from the center? Okay, so if this is the earth and this is Mount Everest, if this is the earth and this is Mount Everest, if this is very big, this is the Mount Everest, and person standing here, he is seeing the earth here, then what is the angle? This angle. Okay, this angle I have to calculate, at which this arc s cannot be approximated same as d. This is d. Person is seeing, standing on Mount Everest, this is d, this is s. If person is very small, he is seeing very near only, then s equal to d we can take. At what angle s equal to d I cannot take. This is our philosophy. If that angle, if we know, if we know, then we can calculate not Mount Everest, we can calculate the distance d at which the person can start seeing the curve. Now see if some person is standing on Mount Everest, the distance that is required to make the this distinction is same or not. If it is more than that, then person can see the curve of the earth. Now, in next phase, we will see all the calculation we have documented. And then we will see that actually a person standing on Mount Everest, the people who went on Mount Everest, they claim that they have seen the curvature of the earth. Very big thing. Even people who are on aeroplane, because of the first they cannot see that nicely. Aeroplane person through window he see down only. Mainly if person is standing on Mount Everest, then he see exactly the surface, flat surface. Tibetan plateau is flat, so he is seeing flat surface and directly means with the angle of 60 degree or whatever. So this Himalaya was raised by an architect called Bhagirath. So Bhagirathi was architect who raised Himalaya and made river Ganga flow. So river Ganga is also known as Bhagirath. Bhagirathi and Ganga, there was a Changi queen or Changi prince named as Changi. There is a Changi airport in Singapore also, Changi airport. And Changiz Khan is in name of Changi only. So Changiz Khan, the real name was Gangesh Khan. Means Changi became Ganga. So the name of the queen, after which this name came as Ganga, the actual name of the queen is Changi. And based upon Changi, there was a powerful king from powerful ruler, I would say, from Mongolia, Changiz Khan. People in English, if you see, it will be written as Gangesh Khan. So Changi and Ganga. So the Bhagirathi river is named to Queen Changi and it became river Ganga. Similarly, with the architect Indra, the actual name of the river is Indra or Indras, but it was renamed after Queen Sindhu. So Sindhu was another queen and it was renamed as Sindhu. But in English, still it is called Indus, I mean Indus. Indus and Sindhu, they are two different names, whatever it is. So looks like Bhagirathi, he designed Mount Everest in a fashion that someone can really see the curvature of the earth. That is priceless. That is really priceless. That is standing on Mount Everest, and if you see far, then he can see earth is making round. I believe this is very different kind of experience anyone would encounter. So we will proceed on the calculation and we can really prove it or not prove it, whatever. That person can really see the curvature of the earth standing on the Mount Everest.